Next question is based on a very important concept of differentiability, and although this question seems to be complicated, but we can solve it with the help of graph. So what is given here is a function which is from R to R, differentiable at C which belongs to R, and f of c is equal to 0. Now there is another function gx which is modulus of fx. Now we have to find whether gx is differentiable at the same point or not. So there are conditions. If the derivative of c is 0, that is of f, and f dash c is not equal to 0. So these are the various options. So let us see the question first. The question is gx is equal to modulus of fx. So let us see everything with the help of graph here. Now if fx is equal to a function, say this, that this is the point C where f of c is equal to 0. Now we know when we apply a modulus here, this part will form a mirror image here. So you can see the mirror image of this part will be roughly here. So this is the gx for us. So this is the gx which is having only the upper part. We have drawn the image, and you can clearly see there is a sharp turn here. Now there is a sharp turn here, that means this gx is not differentiable at this point if we have this shape. Now in this case you can notice that the derivative of function f at c is not equal to 0. It is having a positive slope. So there is a sharp turn. Now if you trace the same graph here such that there is no sharp turn, now how this can happen? Let's see here the same graph of fx. If we have this graph, say this one, and the derivative at c is equal to 0, that means it is just touching at this point. So this is fx for us. Now if you draw the graph of gx which is equal to modulus of fx, you can see you want to draw the mirror image of this part, and when you draw the mirror image of this part, you can see the derivative at this point of gx is again equal to 0. So definitely the function is differentiable if the derivative of the function f at c is equal to 0. So if there is a smooth turning, that is the c derivative is 0, then if you draw the mirror image, then gx is also differentiable at this point, provided the derivative of the function f at c at the same point is equal to 0. So in that case there won't be any sharp turning. So the option which is correct here for us is option number second. So if the function f is having derivative at c equal to 0, then the function gx will be differentiable. If the function is having a positive or the negative value of the derivative at c, then definitely there is going to be a sharp turn and the function g will not be differentiable. So let us move to the next problem. A question from height and distances. ABC, a triangular park with AB and AC equal to 100 meters. A vertical tower is situated at the midpoint of BC. If the angle of elevation of the top of the towers at A and B are cot inverse 3 root 2 and cosecant inverse 2 root 2 respectively, then the height of the tower is. So let us go for the figure first. A figure is important in this problem. So let us see, this is a triangular park. Now, this is A, B, C. There is a point M, the midpoint of BC, at which there is a tower right here. Now, again let us see the angle of elevation at A and at B. So, this is at A and this is at B, right. So, what are the data given to us here is this is A, this is B and this is C, this is M, this is 100, this is 100 as well. Now, we are assuming the height of the tower as h. Now, we are provided with two angles, angle alpha and beta. The angle at A we are having here is cot inverse 3 root 2. So, let us see the angle at A is, let us say this is alpha. So, from here you can see that tan of alpha is equal to h upon AM. You can notice that this is a 90 degree. Now, tan alpha is 1 by 3 root 2. So, h by AM is equal to 1 by 3 root 2, and again the angle at beta, B is beta. So, we are given cosecant inverse 2 root 2. So, we have to calculate in terms of tan as well. So, from here we have tan beta again equal to h upon Bm. Now, if you calculate this, you will have this as 1 by root 7. So, from here we have Bm and from here we have Am. You can again notice here that Am square plus Bm square, since it is an isosceles triangle, is equal to AB square, which is equal to 100. Now, substituting the values in terms of h, we have here Am is equal to definitely h into 3 root 2, the square of this, and Bm definitely equal to h into root 7, the square of this is equal to 100. Now, calculating the h from here, that will give you the value equal to 20. So, the option which is correct here is option number 1. So, again an easier one, a little bit of 3D figure is here. So, let us move on to the next problem. The next question is from indefinite integral, the integral of x square minus 2x plus 10 in the denominator with the whole square. So, the degree is huge, but question is again an easier one. You can check it out here that the option clearly says what should be the substitution. So, first what we are going to do, we are actually going to reduce the degree by completing the whole square. So, concentrate on these two terms, they will make a complete square and the substitution will be very much visible to you. So, completing the whole square first, we can have here x minus 1 whole square plus 9. The term within this bracket sign is clearly giving you the hint what should be the substitution, and from here we can see the substitution is trigonometric and that is 10. So, what we will do, we will substitute x minus 1 is equal to 3 tan theta. So, that is going to decomplicate the things. So, x minus 1 is equal to 3 tan theta, that is the substitution, and from here you have dx is equal to 3 secant square theta, d theta. So, the integral will now become 3 secant square theta d theta, and in the denominator we will have 9 tan square theta plus 9 and again the whole square. Now, you can see this is 3 upon 9 square, that is 1 by 27, and this is again 1 plus tan square theta, which is secant square theta. So, this is what we are having here. So, this will be 1 upon 27 cos square theta d theta. Now, this can be easily done. This is again 1 by 27 into 1 by 2, 1 plus cos 2 theta d theta. So, this is 1 by 54 theta plus sine 2 theta by 2. Now, if you substitute theta with tan, you will have the first term. You can notice here the first term is this, that is tan inverse x minus 1 by 3. So, substituting the theta with x minus 1 by 3, that is tan inverse x minus 1 by 3, you will have this first term, and if you compare, you will get the value of a, that is equal to 1 by 54. So, the value of a will be 1 by 54. So, that is clear. And the second term, we need again the second term here. Why? Because we want to find out this f x. In the option there is f x as well. So, what we have to do? This is actually for us sine 2 theta by 2, and we know what is the value of tan theta. Tan theta is equal to x minus 1 by 3. So, we have to convert this in terms of tan theta. You know what is sine 2 theta? It is 2 tan theta upon 1 plus tan square theta. So, if you find out this value in terms of x, you will clearly see this term when compared with this term will give you the value when you replace this by 2 tan theta upon 1 plus tan square theta again into 2, where tan theta is equal to x minus 1 by 3. This term, that is, will become 3 into x minus 1, and in the denominator you will have this term, that is x square minus 2x plus 10. So, the f x is equal to 3 into x minus 1. So, the option which is correct here is the second option. So, we have completed the solution of 10th April JEE Mains morning session paper, and I hope you must be having all the questions correct probably. So, wish you best of the luck for your score. Thank you.